Hello again. In this video we're going to be working once again with our geometric series. More specifically, we're going to be working through an example that's divergent. So let's review one more time our definition. A geometric series is a series of the form a times r to the n minus 1, which when we write it out into individual pieces, we see that we get a term a plus a term ar plus a term ar squared, where we can see that each consecutive term is being multiplied by an additional factor of r. So, and we know that by the definition, a geometric series is convergent if our absolute value of r is less than 1, and divergent if r is greater than 1. So looking at the example we have here, let's start off by seeing if we write out a series of terms like our definition is, see if we can find our pattern, see if we can find what our identify and find what our a and our r is. So with this series, if you write out our couple of terms, let's first start off with a equals 1. So we're going to have 3 times 2, or 3 to the 2 times 1 times 2 to the 3 minus 1, which is the same thing as saying we're going to have 3 squared times 2 squared. Our next term, we're going to have, our n is going to be 2, so we're going to have 3 to the 2 times 2, and then we have 2 to the 3 minus 2, which is the same as saying we're going to have 3 to the 4th, 2 to the 6th. Let's do one more term. We're going to have our n be 3, so we're going to have 3 to the 2 times 3, and we're going to have 2 to the 3, oops, my bad, this is 3 minus 3, so we're going to have plus 3 to the 6th, 2 to the 0. So here this is a minus, my handwriting is terrible, so this is going to be 2 to the 3 minus 2, so this is going to be 2 to the 1st, my apologies. Okay, so now that we have this written out, let's identify our individual pieces. So let's see if we can figure out what our a is and what our r is going to be. So our a is always our first term. So this is our a, 3 squared, 2 squared. Now our r is what we see multiplied to each individual piece. So from our first term to our second term, we see that 3 squared is going to be multiplied by a 3 squared, and we're going to get 3 to the 4th. And then our 2 squared is multiplied by 2 to the negative 1 to get 2 to the 1st. Looking at our third term, we see that that pattern repeats. Our 3 to the 4th is multiplied by 3 squared to get 3 to the 6th, and our 2 to the 1st is multiplied to 2 to the negative 1 to get 2 to the 0. So this r is multiplied by each individual term, continuing on into infinity for our series. So this pattern of multiplying by r will continue on forever. So now that we've identified our r, let's figure out whether or not this series is convergent or divergent. So in order to do that, let's take the absolute value of what we got. Oops, this guy's not in here, sorry. Let's write that. So what is our 3 squared is 9, and 2 to the negative 1 drops our 2 down into the bottom. 9 over 2 is greater than 1. Therefore, this geometric series is divergent.